So we talked a few videos ago about how we could do exploratory data analysis if we had one categorical variable. We also talked about two categorical variables. Then we moved on to one quantitative variable, and we spent a while thinking about center, shape, and spread. And now we're going to think about a mixture, one categorical variable and one quantitative variable. But before we can really do that, we need to think about a few more visualizations and characterizations for quantitative variables. So we have been eyeballing to find outliers, but if we wanted to be more rigorous, we might use the 1.5 times the interquartile range rule. So the IQR, remember, is Q3 minus Q1. And a value is an outlier if it is smaller than Q1 minus that 1.5 times the interquartile range, or larger than Q3 plus 1.5 times the interquartile range. So let's think about that with my 2019 movies data. I've got my quartiles Q1 and Q3, and that would allow me to compute my interquartile range. Minus 52.6, and I think that should be 201.2, and then we would do 1.5 times that interquartile range, 201.2. All right, so now we've got a value that we're going to want to compare. Maybe I'll move this stuff up so that I have a little more space at the bottom. So I want to know, are there any values that are less than Q1 minus 301.8 or greater than Q3 plus 301.8? So let's figure both of those out. So Q1 is 52.6, and if we minus 301.8, we obviously get a negative number, negative 249.2. I don't think there's any way for a movie to have made negative money at the box office. It might have netted negative money, but our minimum value here is positive. And then the other one, Q3, is 253.8 plus 301.8, and that's 555.6. So are there any values less than negative 249.2? No low outliers. But are there any values greater than 555 million? Yes, several high outliers. I can't really tell how many from this table of data right now, but I know that since the max is 2,798, and that is more than this cutoff, that there's got to be at least one outlier. I'd have to have the raw data to actually pick out how many outliers there were. So there's a visualization of the 5-number summary called a box plot, and box plots were invented by this statistician named Mary Eleanor Spear, and they were popularized by John Tukey, who is one of my favorite statisticians. And the reason why they were invented and popularized is because they're really easy to draw by hand. So they were created before computer graphics were as advanced as they are today, and so it's something that you can just draw with pencil and paper. So the way that you make a box plot, you calculate that 5-number summary, you draw a box from Q1 to Q3, then you divide the box with a line at the median, and then you draw a line from the Q's to either the most extreme value or the most extreme value that's not an outlier. And then if you have outliers, you just draw them as individual dots. So now that we have computers, we can ask computers to make box plots for us. So I asked it to make a box plot of these movies, and I think that R is using something pretty similar to the algorithm that we did by hand. So you can see that there are quite a few movies actually that are above that cutoff where we determined they would be an outlier above 555. So yeah, that looks about right. This should be 500, that's a little bit more. And then all of these are outliers, no low outliers down there. And then you can do something kind of in the other direction, where if you have a plot, like a box plot, you could estimate some of the numbers from looking at the plot. So you could estimate the median, the interquartile range, the range, and you could determine if there are outliers. And I'll leave this one for us to do when we have synchronous class together, but this is again about bill depths of some penguins from the penguins data. So now that we have one final way to visualize a quantitative variable, we're going to finally start thinking about the relationship between one categorical variable and one quantitative variable. So the nice thing is we can take any visualization or statistic that we know for characterizing a quantitative variable. So that would be like a histogram, dot plot, a density, or now we have box plots. Or a statistic, so that would be things like mean, median, standard deviation, and on. And we can break it down by categories of a categorical variable, not level, variable. So this is my general social survey data, where I'm looking at someone's employer, whether they are self-employed or work for someone else. And then I want to know how many hours do they work per week. So I could look at the relationship by breaking down the visualization into two separate box plots. So these are side-by-side box plots. Here's one box plot for all the self-employed people and a separate box plot for everyone who works for someone else. I could also do kind of side-by-side histograms. So here, this is the histogram for someone else. You can tell that the bulk of the data is there. It's centered around 40, but there's like a lot more people in that category. And the self-employed, maybe it's also centered around 40. It's a little bit harder to tell. So when we talk in synchronous class, I'd love to hear if you have a preference between these kinds of plots or some benefits and drawbacks of each of them. But they let you see similar things. We could also break down something like the mean based on the employer. So the X bar for self-employed people is 38.87 hours, and the X bar, I can't use SE, so I'll just put else there. That is 41.61. So those are the means for each of those groups. Similarly to the way that we found a difference of proportions, we could find a difference of means. So we could say X bar for self-employed minus the X bar for else. And again, you got to be careful with your notation, but that would be 38.87 minus 41.61, and I get a negative 2.94. So if I wanted to interpret that, I could say the average number of hours worked by self-employed people is about 3 hours less than the average for people who work for someone else. And like I've said before, we don't have any tools to tell us whether that's a significant difference or maybe it occurred just by chance. We're going to learn about that as the semester progresses. But for right now, it looks like maybe there is a little bit of a difference. It's 3 hours, 2.94 hours, which I'm rounding to 3. So that's how you would break down a statistic by a categorical variable. And it wouldn't have to be a categorical variable with just 2 categories. You could have side-by-side box plots for a categorical variable that had 4 or 5 or 10 categories if you wanted to. And the same thing with means. You could have many means. You don't just have to have 2. But the basic idea is anything that you can do for one quantitative variable, you can break down by a categorical variable to show that there's a relationship.